Real quick, does anyone have to get going by a certain time?
No, I'm good.
So at 9. Okay. We'll definitely be done before 8, but uh, yeah, it should be quick. We're just gonna talk about some stuff. Hopefully, get some coding tasks assigned. And yeah. So first, because this is your first time kind of meeting with our sub team, you guys want to just go around and introduce yourselves, or maybe talk about your day. So you guys probably know I'm Zane. My day's been going pretty okay, I guess. Got to college, my lab got canceled, so I went all the way there for no reason. Just been working ever since. And I guess we'll go in order of the Discord. So, Alex, why don't you introduce yourself?
Anything specific or?
Just your name and anything, like how your day's going, anything.
My name's Alex, and my day's pretty good.
Nice. All right. What about you, Antonio?
All right, my name is Antonio, and my day was good too.
Cool. All
Chris.
right.
I'm Chris, and good day off. It was a good day.
Nice.
Hi, my name is Ashinike, but you can just call me Nike. And my day was good. I was relaxed.
Yeah, that's good. Nice to hear you guys have fairly relaxing, even if uneventful days. It's perfectly fine. Cool. So introductions out of the way. I guess we'll jump into kind of like the content of the meeting. We'll split this up into two main parts. One is just going to be talking about kind of functional programming and good task breakdown conventions. Because as we start kind of coding, it's not going to be each of you writing individual scripts. We're all going to be contributing to one greater project. So we're going to talk about how do we do that in an effective way where we're not kind of clashing with each other. And then at the end, I'm just going to kind of quickly bring up some stuff about the TikTok task, which we have to do by next Monday. So we'll get that done in like an hour. Yeah. So we'll start with the whole functional programming thing. So I'll share my screen real quick. Oh, Paint doesn't want to work. That's it. We'll just go with this one. Clear some. Oops. One sec. Yep, it should be good now. So, wait, did someone say anything in the past couple of seconds? Because my thing kind of.
Nope.
Okay, cool. So, I guess a way you might like to think of computer science in general, and I kind of mentioned this in the coding tutorial I first posted, and Harvard CS50 course. I know my friends at Carnegie Mellon and MIT as well. They kind of like to think of programming as this kind of black box, where you have some input on the right side, goes through this black box, which is like the code that we learned to write our algorithms, and then we get some kind of output. And I'll go over this quickly. It's kind of basic. But on the left side, we basically have our inputs. In the middle, we have our code. And on the right side, we have our outputs. So this is very, very kind of like broad and generic. We're going to be specializing this more and more to individual tasks, where instead of our code being the entire script, it's just going to be individual functions. So what I mean by are you guys familiar, or is anyone, how about this? Is anyone not familiar with what a function is in Python or coding in general? All right, I'm just going to assume we're all good with that. It's basically just something very specific. You put def and then the function name. I have some examples. Let me share my entire screen. Change windows.
How good are you guys with coding? I know we asked you this before, but so we don't just go over things that we don't know. Or Alex or Nike, whoever wants to go first.
I would say I'm pretty decent. Like I'm a average coder, but not like too advanced where I know almost everything in the topic. Like I told you, I know like a good amount of languages and I can code in them really well.
Mm-hmm.
Yeah, I'm kind of like intermediary everywhere. I've done a couple languages.
Okay.
I think I'm like leaning towards intermediate, but I'm not that good at stuff.
It's okay.
Okay.
Yeah.
Nice, nice. So that's pretty good. I'll speed this up then. Basically, this is an example of function. You have your function name. This is the important part. With our functions, we won't be able to write just one long script top to bottom. What we're going to do is we're going to break this kind of greater task, which is converting our netcdf files into the kind of graphs that we're looking for, into individual functions. So you could kind of see that here. One creates intervals, one creates histograms, creates a GIF, and all of these, when you put them together, you're just calling one function after the other. And the reason why we're kind of using this method is so, let's say first you create intervals, then create histogram, then create the GIF. Let's say each one of you are working on each one of these sections. You don't have to write the first part in order for the next person to start writing the next part, if that makes sense. Someone can start working on the middle before the beginning is finished. And that's really nice because it kind of allows all of us to work on different parts simultaneously, so we're not kind of rate limited by the person before us. But in order for this to be successful, there are a couple of things that we want to keep in mind. One is kind of, one second, let me just share my entire screen. Keeping in mind, this should be better, you can see one on the screen. Keep in mind that we have to very clearly define our inputs and we have to very clearly define our outputs in order for our code or our function to be very, very readable. So as you can see here, we just have a couple of things here. This is called a doc string. It's kind of a more general name. This is pretty short. This is not as extensive as it should be. Ideally, you'd say, okay, inputs, max is gonna, and then you're gonna specify the type of something, and then what it means. Spacing is the type and what it means, type and what it means, and then you're gonna specify the outputs or the return values, what that actually means. In this case, intervals is just going to be a list of integers. You want to specify that, and that's going to basically make it so that you don't actually have to write the code. As soon as you write the documentation for each of these, the next person can kind of just like assume the previous functions work as intended, and then they could code up whatever their function is and figure all that out on their own without necessarily, again, being rate limited by the stuff before. So to summarize, what I'm talking about task management is breaking down a big thing into smaller parts and making sure that those smaller parts are well defined in terms of their inputs and outputs, such that people before or after you can work on their parts without necessarily having your code. If that makes sense. Does anyone have any questions on that?
To Zane's point, also, you can look at the code that Zane had. Like, there's always comments. Make sure you comment what you're doing, just in case like a problem appears like 3 weeks ahead of time. You're like, oh shit, this line has a problem, but I don't know what this line is about. If you have comments, it'll let you know what you were doing because you're gonna obviously forget. And also, when you're putting the code together, it'll help out when you're working in teams when it comes to coding.
Yeah, commenting is very, very important. Yeah, it's a great point. So yeah, that pretty much goes over. Yeah, any questions about task breakdowns? Cool. So I guess what I wanted to go into now is just kind of with this idea in mind of breaking down our script into multiple different individual functions. I wanted to just kind of spend some time with you guys brainstorming, and this is in the folder, but I'll share it with you guys as well. This is team 2, right? Yeah. If you guys want to hop on this doc, and what I was thinking is that we could just spend some time taking our script and just, I wanted to give you guys the opportunity to kind of try and break it down on your own. So one thing that I'll clarify, if you go back to my stream, let me undo all of this. Basically, in terms of our entire project, what we basically have is we have a bunch of netcdf files that we've pulled from the Go satellites, and these are like arrays of float values, and they kind of go over time, so it's kind of a three-dimensional array if you like to think of it like that. And then what we want is a graph that's essentially you want time on the x-axis, and we want to have cloud cover. Let's call that CC on the y-axis, where it's basically saying what percentage of the North Atlantic was covered by clouds at the time. So what we expect is that if this time is over the course of a hurricane, then there's not many clouds, and then there's a lot of clouds, and then it kind of dies down, and it goes like that. And we expect hurricanes to have this general cloud cover plot. So our input is going to be the netcdf files, and our output is going to be this graph that kind of represents the cloud cover over a region. So yeah. Yeah. At this point, just pipe up, type something. Feel free to say anything. At this point, we're just discussing, brainstorming different functions, names, inputs, whatever, that we can break down this task into. So yeah, go for it.
Wait, can you please go over like the input output a little bit more?
Yeah. So for our input, it's just going to be here. Let me. Oops. The input is going to be some netcdf file. So are you familiar with the netcdf format?
Yeah.
Oops, one sec. My headphones got unplugged. One sec. Okay, I'm good. Yeah, it's basically what we were reading with Panoply. Once you, it's a little difficult to start, but it's basically just a 2D array, and it's going to have a bunch of double values in there that you can read with Python. You just kind of play around with it after a bit, and you'll get to use it. You'll get to learn how to access the individual values. It's something we'll learn through trial and error. So that's the input. In terms of the output, like I was saying, is the time cloud cover thing. So what we could do is let's simplify this entire array. Let's just say it's a 2x2 array. And the numbers here are like 5, 0, 10, and 6. These are the values in the netcdf array. Of course, it's going to be like a 10,000 by 10,000 array. I'm just simplifying it to a 2x2 array. When I mean cloud cover, what I'm saying is that let's say we choose some threshold of, let's say a cloud is anything that's, I don't know, let's say 5 pixels or greater. Greater than or equal to 5 pixels is what constitutes a cloud. So what we're going to do is we're going to loop over this array. We're going to find, okay, this first pixel, is it greater than 5? Or is it greater than or equal to 5? Yes, so that's one cloud. 0 is less, so that's one non-cloud. 10 is yes, so it's one cloud. 6 is yes, so it's a cloud. And so we have 3 cloud pixels, 1 non-cloud pixel, so that's a ratio of 3 over 4, a ratio of 3 to 1. 3/4 of them we could consider clouds, and so our ratio here would be 0.75, and then you put a data point there. And then let's say on the next one, this value was a 0. Let's say we step forward in time. So this is our initial time, and we step forward. This is a 0. Then the new ratio for this would be now only 2 are above or equal to 5. So this would be a 0.5. So it would go down. And so we kind of just continue this over, and we'd kind of, yeah.
Okay, wait, so then the frequency would be the y-axis, while the like x-axis would be what?
X-axis is just time.
It's time?
Yeah.
So like the 2D array is going over, like the rows in 2D array are going down by like time.
No, so sorry, I should have specified this more. The way the array works is that each 2D array is going to be kind of a snapshot in time. And then the netcdf file itself is going to be a set of 2D arrays. It's going to be like 1,000 2D arrays, and each individual 2D array is going to be the values over some land.
Okay, that makes more sense.
Yeah, so this is going to be like the longitude. This is going to be the latitude.
Latitude, yeah.
Yeah.
Okay.
And then this is going to be at, let's say, December 1st. And then there's going to be another one that's going to be December 2nd. That's identical in format, but the individual numbers are going to be different.
Different, yeah. Okay,
Okay.
that makes more sense.
Wait,
Cool, yeah.
sorry, just for clarification. So when it generates a point in the graph for cloud coverage, what is the, like, does it just take longitude over latitude in that sense, or?
Could you repeat that? Sorry.
Like when it's putting a point for a specific time value, right from the array, is it just taking the longitude over the latitude as like a ratio, or is it?
What it's doing is it's looping over every single value in the 2D array at that. So let's say we have December. Let's say this represents December 1st. We're going to have a 2D array for December 1st. It's going to loop over every single individual pixel or every single, I guess, cell in the array. And it's going to see, okay, how many of these are above our cloud threshold, how many are below, and then what percent of them are above, basically. So really just counting the total number of pixels and the number of pixels that are above the threshold.
So defined, or is that something
What's
that we need
defined?
to figure out?
The threshold?
Yeah.
Oh, that's something we'll figure out on our own as time goes on. I'll let you guys figure that out
Okay.
yourself.
Gotcha.
If you want a hint, basically it's just going to involve looking on Panoply and just looking at the pixels and saying, okay, what looks like a cloud, what doesn't look like a cloud. It's very arbitrary, but you'll see through experimentation that it doesn't fully matter what we choose as long as we're consistent. But yeah. Cool, cool, cool. Any other questions? All right. So if you want to get on the doc, I guess what are some basic ideas for what we could do for our functions? Does anyone want to?
So like, oh, I was just thinking that like one of our functions definitely have to be like looping through like the 2D arrays.
Yeah, perfect. Yeah, you could write that down on the doc. Here, sorry, let me.
Oh, okay.
Yeah, we could just make a long list of them. And feel free to write it in. Make one is like looping through the 2D array. So make sure we want to define our inputs and outputs. So what would be the input of that and what would be the output of that?
Would the input be like yeah, so would the input be like the net CDF files or
Yeah, good. So we get
okay.
in, yeah, so, and I'm gonna ask some challenging questions. Is it gonna be one net CDF file or multiple net CDF files? And there's not even like a single right answer. You could implement this a number of ways. We just
Ways I
wanna
know.
choose
I
one.
was just thinking about like one net CDF file
Yeah.
alone, because like when you have one, you can reuse this set like of helper code to like do on multiple days.
Yeah, absolutely perfect. So
I
we
think
could
that
have
makes
one
it
like,
easier,
yeah. Loop over 2D net CDF array.
In a sense, wouldn't it also be possible to like use a 3D array with one very large netcdf file?
Yeah, if we wanna create another function that kind of compacts all of them down into a 3D array and then kind of loop
Yeah,
through
that's
that
the
works
one
as
that
well.
I did before, so we can
Yeah.
maybe use that.
Yeah, we could do that, and that uses Xarray. In this case, to keep it simple, because some of the people in the other teams are kind of beginners, so using 3D arrays might be a bit complicated for them. Let's just stick with the way that Nikkei lined out. But your way is valid too. The Xarray stuff
Yeah.
is cool too.
Yeah, I just wanted to know if that's valid as well. Okay.
Yeah. So our input for this would be said one net CDF file, and then what would our output be?
So I was thinking about returning a double value that like gives a ratio of the number of clouds you see, and then divided by the number of like total data numbers there are.
Yeah. Ratio of cloud pixels to total pixels. Cool. Yeah, and then you'll see that there's not really any actual code here. Oh, I just want to show you guys. No, I
Quick
think I
question in
did.
terms of like
Yeah,
how
go for
the histogram thing works. So if the histogram is considering it over time, how would we, if we're only looking at one netcdf file at a time, how would we?
Yeah, so there's two things, and you can look back at my screen share for the
Yeah.
thing. So there are two graphs that we could make. One is visual and one is actual informational. So the histogram, if we were to make a histogram, that would kind of be I think I have a histogram for that. Yeah, so here's an example of a histogram that we might make. It'd be so a histogram we could only make for one single moment in time. This would be a single 2D array. And I didn't label my axes, sorry. These would kind of be like the cloud thresholds. So what you'd see is that in between, there are this many pixels. Here, I'll copy paste this. Oh, no, you can't see the things. Cool. Basically, if you look in between here, these are the number of pixels that are in between whatever y value is here, and then this would just be the number of pixels, if that makes sense. But this histogram isn't as useful because it only gives us one moment in time. What we're more looking for is this kind of time versus cloud cover graph, time cloud cover,
So
which has multiple times.
if we're looking at time, wouldn't that have to require like either multiple like running the function for multiple netcdf files and then using then putting that all into one array, or just doing it as one large one?
Yeah, very good concern. So, sorry, I'll start from the beginning. That's a very good concern. So we have something right now that loops over a 2D netcdf array, but how are we going to do that for the rest of the netcdf files? Do you have an idea for a function that could do that?
Not off my head, I'm still thinking about it.
No, it's okay. Yeah, you could think about this over some time. We got
Well,
maybe, yeah.
like, couldn't we just use the same, if each 2D array is like one point in time, don't we just use the same function on each point in time and then calculate the ratio for each like point in time and then just plot ratio per time?
Yeah, perfect. That's what we'd end up doing. Is that, yeah, Alex, you want to say something?
Oh no, sorry.
You know, yeah, we just do that. And Alex, you were kind of getting at this before too, I noticed. Yeah, we just want to repeat this over and over again for all of the individual netcdf files for over the period of a hurricane, or sorry, all the times associated with the netcdf file 2D array over the period of the hurricane, if that makes sense. And from that, we're going to get a set of times, or a set of time values, a set of associated threshold, or sorry, ratio values. We just plot those as versus, yeah, I'm just repeating what you said. Yeah, perfect. So why don't we try writing that out as a function right below this? On the dock, yeah. You can go for it, Chris. You there? Yeah, anyone can just kind of write it out, yeah.
Oh, just write out like the code.
And not the code, but like kind of like a description of the function, the inputs and the outputs.
Oh, okay.
Yeah, go for it. My bad, sorry, I wasn't clear. Write it right here underneath loop over 2D netcdf. Yeah, there you go.
Number 2, yeah.
So you want to be careful with the ratio of pixels thing, because that's what we already did with our previous loop net, or whatever loop function that we have for
Oh,
number
you
one.
wanted like, my fault. I thought you wanted like
Yeah,
the
you're
whole
good.
thing. So,
No,
okay.
you're good. Right now, so this is a function that'll loop over them. Now, like you said, we want a function that will call this one multiple times in order to construct a thing. And this will kind of require more intimate knowledge of matplotlib and how we actually store points and then graph them later on. But in general, you have an idea where we want to call this function over and over again, collect the points, and then graph them. Yeah.
Yeah, sort of.
We can get rid of this much, I think. Yeah.
Yeah, okay.
Is that what you were kind of getting at, or
Um,
2D?
yeah, sorry, Google Docs. So yeah, we already have the one netcdf file. We should clarify one netcdf file for a specific time. So the one netcdf file will be associated with a specific time, and that's going to give us one time cloud ratio point, right? So this should probably give us the ratio of cloud pixels to total pixels, and then also this will probably also give us a time value. And so that's going to give us 1 point on our graph. So now what we want is we want multiple points on our graph, right?
So we could use like, if each netcdf file is like numbered per time, we could do like a for loop and loop through each netcdf file and store the functional value as the y, and then store the time as the x, and then
Yeah.
just put that into like a matplot.
1 sec. Yeah, sorry, I cut out near the end, but no, that's absolutely perfect. Yeah, so why don't you try writing that out on the doc? Write out a function that kind of describes that, yeah. So you can kind of rename this part. Or, yeah, no, that's fine, yeah. Loop function for separate files, yeah.
When I was compiling the netcdf file before was that the way that they formatted time was a bit odd, so that might be.
Yeah, it's confusing. That's something you'll have to work through with implementation. And it's something you'll have to like very much specify where the function after you has to trust that you've done that the right way. So
Right.
Yeah.
you want to specify that in your documentation. And just as kind of like a note, the reason why I'm teaching you guys this, like when you're writing a project on your own, you never have to worry about this kind of stuff. You know what you're doing. I'm kind of teaching you this because as you work on big research teams or on a company or on an internship, your documentation and your unit testing and all this stuff is so, so important. You will get kicked from your team if you could be the best coder in the world, but if you can't write good documentation, you'll get kicked from the team. Uh, yeah, I've heard this happen to a lot of people. My friend goes to CMU and he has horror stories of upperclassmen who have gotten in a lot of trouble because they can't write good comments and stuff. So yeah, it's a little hard at first, but we'll get used to it over time. Just something you got to practice.
They do the seconds. I don't remember.
You can leave stuff blank for now. Kind of just want to get the idea.
Okay.
And I guess as you guys kind of work through number two, if you're still typing stuff for number two, keep going for that. I'm going to talk a bit on number one. So for number one, how are we determining the cloud pixels again? Does anyone remember how we're doing that?
The
I
ratio.
thought we were using like a test case where
Uh,
like we check. Oh, good.
No, go for it. Go for it.
Okay, I thought we were using a test case where we like check if it's like a certain amount, and then if it reaches that certain amount, then we say it is.
Yeah. Colloquially, I like calling that value a threshold. That's what I'm going to refer to it
Threshold.
from now. Yeah, I
Okay.
just like calling it that. That's not like an official name. But yeah, it's a threshold where if the value in the 2D array is greater than this, then it's a cloud. And if it's less than this, then it's not a cloud.
It's not a cloud. Yeah.
Yeah, so how is this function going to know what that threshold is?
But if you use like a if statement that like checks,
Yeah, nice.
and we use I would say variables to like you to use and check.
Yeah, cool. Yeah, we got cloud pixel and total pixel. So the thing that I was trying to get at, and I'll just tell this to you guys, is that you want to be very careful for this input. We might define the threshold early on, but you'll know that the input for this function also has to be a threshold. We have to give the function a threshold to use, right?
Mm-hmm.
So yeah, that's another additional input that we could add to this function. Output, yeah, very good.
it's not considered a cloud, we just disregard the amount of pixels in it? Or?
Yeah, so I think for every single pixel, we want to increment total pixel.
Yeah, that's what I was saying. Yeah.
Yeah. And if it's underneath or above, it might be below. It's either above or below the threshold. I forgot. You figure that out, don't worry. And I'll help you guys with that too, don't worry.
Yeah, didn't you say it was the opposite? It was
It was what?
I think one time you said it was like the opposite.
Yeah, I remember I flipped them at first, and all my graphs were upside down, and bothered. It gave me trouble for like a week until I finally figured it out. I just had to flip a single sign, though. That's something you could figure out. But yeah, if increment cloud pixel if it's above a threshold, and total pixel every time. The reason why, I won't give it totally away. This is something that I kind of want you guys to figure out through experience. But as you go through the netcdf file, you'll find that some at the edges, the values get really weird. I think at the edges, the values are always 0 or they're always like a billion or something crazy like that. So you might want to have some checks to see where if it's like greater than 0. That's why I say you want to increment total pixel. We could just do like the total pixel could just be like, if it's a 10 by 10 array, then the total number of pixels is 10 times 10 is just 100. That's obvious. But you could also increment over each one, check the value to see if it's something absurd, and then if it's not absurd, then do the checks in total pixel and cloud pixel. That's just a little food for thought.
So like before we check, we have to check if it's if the number is like valid.
Yeah.
Okay.
You'll kind of get an idea of that as you kind of look at panoply and look at the netcdf files more. Right now we're just kind of doing conceptual stuff, but that's just a hint.
Okay.
Fine. Cool. Ratio clouds. Cool. So let me look at what you guys wrote. Loop function. One for separate files. For loop pulling. You are writing a graph. Okay, good job. Call function 1 time is x. Yeah, cool. Yeah, and this is where you guys kind of want to look at the documentation from Matplotlib. I'll just leave a comment here for like how to make plot graphs. Matplotlib. That's where you're going to kind of start your research. You're going to look it up, see test cases, see how you're going to format it, the functions you're going to have to call, how to set axes and stuff. But yeah, it's something you'll figure out later on. Oh, my headphones are unplugged again. Sorry, this is being really annoying. Okay, I'm back. Sorry. Okay, cool. Yeah, so we have 2. One. Yeah, sorry. Go for it.
Oh, so I'm saying I just dropped the documentation for.
Oh, cool. Yeah, awesome. Yeah, reading through documentation is a very good skill as well. Nice. Cool. So that's these 2 functions. So far we have a function that goes over a single one, over a single netcdf file, and another function that calls the first function to go through a set of netcdf files and come up with a graph from that. Very good. I'm gonna ask some more nitpicky questions. So we're going to be using Google Colab to kind of write all of our code together, just because I don't want you guys to download like 10 gigabytes of data onto your own computer to use the data locally. I've stored a lot of it on Google Drive, and some of the tasks are going to be downloading more data from Google Drive. This is something you have to figure out. You might want to write another function to get the data from Google Drive, and then kind of import it into Google Colab for use, and then take all those files. Yeah, this isn't good at the beginning. Yeah. Sorry, and I'll just leave this link here. I don't want to give you guys too many answers. It's something we'll figure out. Cool. Yeah, so we have a couple ideas here. Something that I'll recommend here. Yeah, you guys probably won't know much about this right now, but as you kind of learn how matplotlib works, you might want to make the thing that actually makes the graph its own individual function. Right now we could leave this here, but as you actually start coding this out, it's okay to make the graphing thing its own function instead of cramming it all into one. I might have an example of this somewhere here. Yeah, in my version, I literally have a make graph that's like 2 lines long. It's okay for your functions to be like super short, where it's just like it calls another function or it loops over one function multiple times. Yeah. Cool. Helper functions for several files. So we want to make sure we always define our inputs and our outputs. So kind of our outputs. Okay, not shift tab. Okay, never mind. So, oops. These are kind of our outputs. For this loop function, what do you think our inputs are going to be? You guys could fill this out. If we're going to be looping for several files, what are you going to need?
Is it 2D array?
So that's what
Wait,
this
no,
one
sorry.
is doing. Yeah.
Yeah, that's what that one's for. Is it going to be the ratio and the time?
Ratio and time. Oh, the things that let you graph them. So
Yeah.
that's what this is
Yeah.
outputting, right? This is going to output the ratio and the time. Or this is going to give you an individual one, and then this is going to give you the one for all of them, right?
Yeah.
So those deal with the ratio and time.
Is the input like the function?
No, we could just call the function. Assuming they're declared in the same thing, we just call the function. That's a good idea. It kind of ties into the first function on the document.
Be the values from function one.
Values from
Not
function.
function.
Those aren't an explicit input. We're gonna kind of call function 1 within function 2. Sorry, no, we're gonna call function 2 from within function 3. And so that's gonna kind of be internally calculated.
So is it like the index?
The index of what?
So like we called, so like each netcdf has an index, and then in function 3 we call function 2 to like calculate the stuff. So would we be inputting the index of the thing we want calculating, and then we put that into 3, it like calculates that through 2, and then 3 like makes the plot?
So you're getting the right idea. looping over each single netcdf file. Each one of these is going to have an index, and those are probably going to be indexed by time, or those are going to be indexed in the form of an array. So function 2 is going to give us a ratio and time, and that's just going to be one plot. There's going to be one point on our graph. We want multiple points,
Yeah.
and that's the reason why we're looping over several files. But here's a bit of a hint. How is this third one? How is it going to know what to loop over?
By inputting, I wouldn't say necessarily like a 2-day array, but like the value, like each point, like a point for each, or point for each day, if that makes sense.
What do you mean a
So you're
point?
talking about like intervals for
Like
the
intervals, yeah.
Not exactly intervals. Hmm. So you're saying you're saying that we should input a time value or something else?
No, like I feel like we should have like a data value that allows us to have like a point represented as both the time and the ratio, but like multiple different points stored in one.
Yeah, that's hopefully going to be the output of this one, where we're going to have like
Oh,
an
okay.
array of x values, an array of y values, an array of time, and an array of ratios. Because this will produce one pair, one xy pair, or function 2 will produce one xy pair. Function 3 will produce multiple, so that you could create like a continuous graph. Yeah. I'll just kind of say, and this isn't completely obvious. It's a little subtle, especially because you guys probably haven't ever used Google Colab before. But something that you'll need for function 3 is, since we're looping over files, the function needs to know, okay, what files am I actually going to be looping over? So that's something you're going to kind of have to determine as you go on. Is that, how do you pass, like a set of files to a function? Do you just pass the name to them? Do you have to pass like some pointer to some path in your system? Do you have to a Google Drive folder? So that's something we'll figure out. But just vaguely, you could put a set of netcdf files over the course of a hurricane. And so function 3 is basically going to loop over all of the hurricane files, and then it's going to calculate the kind of time versus cloud pixel pair for each individual one. It's going to put them all together into a graph, and then it's going to output that graph.
More sense.
What's up?
That makes a lot more sense.
Yeah.
So we're just gonna make this one an entirely different function then?
Yeah. You could leave it in there for now.
Okay.
Yeah. As you learn how Matplotlib works, you could leave it. You could fully leave it in function 3 if you want. Just might be easier to break it up into another thing, just so one person can work on graphing while another works on the loop, because this is a lot to combine into a single thing. Ideally, each function should have like one purpose, and it should be like the smallest purpose it could have. If you could break a function into 2 functions, then you want to break it up wherever possible. Within reason, of course. So yeah. So far we want to get the data from Google Drive. We want to loop over a single netcdf file, or we want a function that loops over a single netcdf file, but we don't use that right away. We use that in function 3, which will call that for every single individual netcdf file. It's going to generate a point. Sorry, I'll rephrase that. Function 2 generates a point, and we're going to use function 3 to generate multiple points by repeatedly calling function 2. And then we're just going to plot that all using Matplotlib. And then we're going to get, if you look at my stream, we're going to get things like this. This represents Hurricane Sandy, where it's just going to be time on the y-axis, percent covered on the, sorry, time on the x-axis, percent covered on the y-axis, and then just kind of over time, how much is it covered. And threshold is just arbitrarily set. And then something else you want to factor in is what band are you using? So this is something that we don't have to define right now, just 'cause it's a little confusing. Oh, I think I unplugged again. Yeah, sorry, that keeps happening. My new headphones are coming. So. Questions. Which band are we using? And this is something that you could kind of determine experimentally or just play around, see what you like. There's no right or wrong answer. You just have to have a reason for your answer. If someone asks you, why'd you choose this instead of this, you should have a reason. Not one single correct answer, though. So
I
yeah.
already have like the data for like 9 of the bands, so.
Wait one second. Okay, I'm so sorry this keeps happening. What'd you say, sorry?
No, I'm just saying I already have like data from 9 of the bands, so it shouldn't be an issue.
Yeah, and if you'll look in the folder, or you could just look in my stream, there's in the albedo research folder, if you go to, I think it's the hurricane data folder, I kind of started making a couple of folders for Hurricane Sandy, Hurricane Ingrid, and this has all 19 bands of data. So basically what you want to do, you want to run the script for all the bands and then see, okay, is there general agreement? Like, do all the bands show the same thing or do some bands show different things? If they show the same thing, then you're pretty much fine. If they show different things, then you want to see, okay, which bands are we choosing and why? Like, are we choosing the high wavelength ones or the low wavelength ones? That's something we'll figure out later, but yeah. I think we could leave off for here. Made some good stuff. I think on the weekend, if you guys want to get started coding some of this stuff, completely feel free. If you want to look into double loops or how to work with netcdf files in Python, or how to work with matplotlib in Python, or as functions in general, feel free to do that. Do a little bit of work. Just put it on the doc. This Saturday, we'll probably come together and we'll combine all of these into one. And as a team, we'll have like a set of functions formalized, and we'll start assigning functions to individual subteams. Yeah. And then one last thing I wanted to go over was that we have to do this TikTok thing. Just stupid. Yeah, we have to make a 60-second presentation, and it's due next Monday. I'll post some information in the Discord, but just, you don't have to do this right now. Just start thinking up some ideas. Wow, message too long. Yeah, just get started thinking of some ideas for like how we could present this in terms of a video project. Yeah, any creative ideas would be very much appreciated because I am creatively challenged.
Yeah, I'll just come up with some on next week Saturday, and I'll show you some.
Yeah, that sounds awesome. Oh. Yeah. Yeah, that sounds awesome. That'd be really nice. And then I'll tell the other subgroups about this stuff. And then next Saturday we'll convene. We'll kind of combine everything that we've done in our individual sub-teams all together. So yeah, in your own time, like I said, if you have, it's perfectly fine if you're busy over the course of the week. I know we're on a Monday, so thank you so much for kind of taking your time on a Monday night on such short notice to come out and talk to us. If you have some extra time, look into some libraries or start writing up some pseudocode or start writing up some code or maybe formalize some functions. If you want to do on the coding side, on the TikTok side, read over what I sent and try and come up with some ideas on how we could creatively represent our project. Because I have no idea how to make albedo into something interesting. It's pretty boring. It's cool, but it's boring. Yeah. Any last questions?
I'm good.
Cool. I'll post a recording for this on YouTube later on. It'll be private, so only you guys could see it. And yeah, that's all. If you guys want to stick around until 8, that's perfectly fine. Otherwise, you guys are free to go. I hope you guys have a nice night.
See ya.
See ya.
Okay,
Good
bye
night,
bye.
everybody.